Hi, I'm Phil and you're watching The Joy of Electronics. In this video, I'm going to continue the Stripboard build of an orange squeezer guitar effects pedal. It's a compressor. You can check the previous video for how we got to this point with our Stripboard cut with jumpers attached. I've got the Stripboard layout down here, and in this video we're going to be populating some, if not all, of the components. So when taking on a project like this, I usually make a parts list in Excel, and then I figure out what I have on hand, and then sometimes I have to order things, which I did for this build, some capacitor values I didn't have, some resistor values, that sort of thing. So then I order them and I keep track of which ones have come in and which ones I'm still waiting on in that Excel spreadsheet, and then I go through and put them aside into a little tray so that they're ready, and I know I've got everything when I get to this point. It's pretty frustrating if you get halfway through a build or almost completely through a build to find out that you're missing a resistor value or a capacitor value, and you have to stop and either make a trip or place an order and wait for that to come in. So hopefully that won't be the case here. Hopefully I've prepared well enough. So let's get to it. I'm going to start with resistors, and I'm looking on the board, and I just go right to left, top to bottom, just as if I was reading, and the first resistor I see is 82K, and now that is one of the values I think I had to order, and I've got them here from DigiKey. So the interesting thing about these is that they're smaller than most quarter watt resistors. You'll find that sometimes when you order these days, you get tiny ones, even though the regular quarter watt resistor is about that size. But it is what it is. They're rated to quarter watts, so they will handle that. So you just have to trust in technology. And let's take one of these out. So for bending, I have these needle nose that I use. They work very well. So let's see where this goes. 82. I'm going to navigate from these cuts and these jumpers because I still have to cut a lot of this board off. It's going to get cut along here and down here, but instead of trying to figure out where the circuit starts, I'll just count back from the cut and the jumper. So this resistor goes in just over from this cut into the second hole, so right there, and then it skips 2, and actually it skips more than 2, it skips 1, 2, 3, so it skips 3, 1, 2, 3, and then goes in below. So it goes in one below this jumper and skip 1 over from the cut. So we'll bend that one end and we'll kind of see what the sizing is like. So it's there and then about there. Like kind of nipping it with the pliers, and then I can I can bend fully once I get it out. So there we go. So to check again, we're at 1 over from the cut and 1 below the jumper. Not too bad. So again, you want to bend these so that they stay in place when you're soldering, but you want to bend along the bus lines. You can see the bus lines are heading in this direction, so you want to bend. I find what works is you bend one way and one the other way, and that works really well as far as keeping that in place. So we've got one. Next we've got 4.7 meg resistor is below it. I'm not sure if I'll need another 82K. I'll check my parts list. It says I only need one. That's it up here, 82K1, so I'm pretty safe to put these away unless I made a mistake. So we'll put them away, but we'll keep them in sight, and we'll start looking for the 4.7 meg resistors. So at some point I bought a large pack of resistors, and they come on tape like this, and with terrible handwriting telling you what they are. So as I use these, I usually go through and I'll put new markings of their values in my handwriting. So 10K, 470K, 1.5K. I'm not seeing it here. What are we looking for again? 4.7 meg. Oh, there we are. 4.7 meg. It's in a bag. So one of these, and this one crosses 3 again, but it's obviously a bigger resistor, so the bends have to be closer to the resistor itself. Looking at skips 1 and then crosses 3, so skips 1, 2, 3, so we pretty much have to bend it right at the resistor on the other side. So you know what, I'm going to rebend it. So to flatten these out, if you want to rebend, is you get, you know, the broad section of the needle nose and just flatten the bend. That's a bit too close. I'll do it again. I mean, you can do this a number of times. You obviously don't want to do it too much because you might end up snapping it, but they're pretty resilient. So that's skipping 3. Now this illustrates the size difference between these two brands of resistors quite obviously. We've got kind of the old style quarter watt, and then some of the new material or new manufacturing quarter watt that's more resilient, and therefore it can be smaller and it can still handle the same load. So there we go. We've got 2 resistors in. I'm going to go ahead and populate the rest of the resistors, and then we'll continue the video after that. Resistors populated, and as you can see, we've got quite a mix here. We've got different colors and different sizes. We've got 2 here that are, you know, the extra efficient or extra robust tiny ones that can still handle the same wattage. So I'm not worried about those. So I was considering on this build populating everything and then soldering, but now that I'm looking at it and I'm looking at the underside here, which is already quite cluttered, I'm not going to do that. I'm just going to go ahead and solder these in place and then go on to the capacitors or whatnot after. So I'm just going to go ahead and start soldering, and I'll solder a couple and then we'll move on to populating the next components. You want a nice fine tip on your iron when you're soldering strip board. Obviously, a lot of things you want a fine tip, so invest in a good one. That way you're going to have less issues with bridging the traces or the buses with an iron that's not as precise. There's a lot of these, so I'll probably have to stop and trim some of these leads before I can do them all, just so that I have the right access. But I'll try to do a bunch. So I'm going to go ahead and solder the rest of these and then trim the leads, and we'll move on. So we've got the resistors populated and soldered. Now a bunch of these wanted to shift around after I soldered them, so my general approach to that is to kind of reflow the solder on this side while I'm pushing up with my finger or fingernail on the resistor on the other side. Just have to make sure that the solder flows properly again, and it's going to make a good contact, and you're not just and push gently so you're not lifting any traces, but that works pretty good. So as I've said before and in other videos, you want to populate components from the lowest height to the highest so that you have access, and it's not too tricky to get into those low components. They can be overshadowed by large capacitors or sockets, of which we have a couple on this circuit. So next I'm going to do the diodes, which are quite small. This is a 1N34A. Another part I had to order that I didn't have on hand, and it's going to go right beside our 100K over here. So 1, 2, and the third up. So 1, 2, and the 1, 2, and the third up, down to where it is. So now with diodes, you want to match up the little black line on the diode. You can see it there with the black line on the circuit diagram, and that tells you the orientation. You can't really see it on this circuit diagram because it's in black and white, but you can just make out that there's a darker spot on the diode, and it's at the bottom there. So 1, 2 up. So our diode goes right in there. Now, since the diode is just a single one, we can put some other components on before we get to soldering. So next we'll do capacitors, I would think. And we've got 47N over here, so 47 nanofarads. I think I've got some here. This is 0.047 UF, which, if I'm not mistaken, is 47N. There we go. So we'll pop that guy in. And he goes, we actually need 2 of these, so I'll get them out too. I'm going to do 2 of them. And you can use film box capacitors like this, or you could use ceramic capacitors, these non-polarized capacitors. It doesn't really matter. I mean, some people will tell you some sound better than others, but you're generally okay. I think I'm going to run into a problem here because these leads aren't very long. So that one's going to fit all right, but the next one is supposed to span across 1, 2, 3, 4, 5 traces, and that's just not going to work with these leads. Really 5, and I'm not sure. 1, 2, 3, 4, 5, 47, and you know, I might have to use different caps for these. So I'm going to put these away. I'll use something with longer leads. So thankfully I have something on hand in this capacitor kit. It's 47N. It's got kind of a little map at the top and then a bunch of what they call automotive grade capacitors. So what do we want? 47N. 47N 50 volts. That should do. So there's 2 of those. I mean, I was lucky I had those on hand. That's a perfect example of when you might have to stop a build because you don't have a part. And that would have been a case where I had the part. It just, I mean, I could have rigged up something, added some wire to the capacitor to get it to span that distance, but it's a bit too hacky. Since I have these on hand, I'll just use these. Just have to straighten these leads out. Okay, so this one is going to go, I'm going to guess about there, but we'll see. And then there. Well, that's not bad. looks like it was meant to be in line with the other 47N. Hopefully I don't run into that again, because I'm not sure I have capacitors with that lead length on all these other values, especially this next value, 2N2. So that's 2.2 nanofarads, or 2200 picofarads. Sure enough, I've got more with these short leads, and this one has to span 1, 2, 3, 4. So I think I'm in the same boat, and I don't think I have another form factor of these, unless I go down to a ceramic, which would be a shame. This one has to go from there. Yeah, that's just not gonna work. So that's too bad. I like the look of these 2200s. I think I do have ceramic ones. These guys. I'm not sure the voltage rating. They look pretty tiny. That's not going to be 50 volts, but we shouldn't need 50 volts. Just look up there, 222, which is the code, and hopefully 222 is what I thought it was before. 222 is 2.2 nanofarads, so 2.2 nanofarads. So that these will work. They just don't look as good. And like I said, I'm not sure the voltage rating. Hopefully these are going to withstand this circuit. They do have long leads, and that's what we need in this situation. I believe these ones came in a another kit of a whole bunch of different capacitors, ceramic capacitors. So those kits are good to have on hand to fill out the values that you might miss from buying components, as it has in this case. These caps are not polarized, so it doesn't matter which way they go in. Either side, either direction will work. Okay, so I think now we're getting on to the larger caps, 2N2. So now we're up to electrolytics. So a 4.7U. Put these aside. 4.7, 50 volts. Now, the strange thing about this, one of the strange things about this circuit, I'm not sure how many strange things there are, but it's got different orientations for the electrolytics. We've got some that are sitting upright, and then some that are axial, or they're shown as axial. Now you can lay those out with these radial ones, but yeah, it's just strange that they show them on the layout in the two different orientations or two different form factors. I don't have any axials, or I might, but I'm not going to look for them. I'm just going to use these radials. So this one is 1 over from our 390, and 1 down, and it goes across 2. 1 down and 1 over, so right here. And for these, you want to line up the line of white, which is negative, with the line of white on your layout diagram. You don't want them to sit right on the board, but you don't want too much height, because that's just taking up height in your enclosure that could be used for other things. It generally makes it more cluttered. So that's one 4.7U, and we've got another 4.7U in kind of a different orientation. So to lay these out like an axial would be, you just gotta bend the leads out like so, and then bend them down to go through the circuit board, and you basically have the equivalent of an axial. It's just going to stick up a bit higher and maybe not look as nice. Okay, so this one is going to go in there. And here. Okay, now we're moving on to 47Us, which I've got a huge one. That's 100 volts. I don't need that. So, and the other ones are 25 volts. 25 volts would do. I mean, 25 volts will do for most guitar effects pedals. It doesn't hurt to use 50 or 100. It's just space constraints at that point. So, I'm going to go ahead and bend this one and finish up the rest of the capacitors. And then I'll solder them in, and we'll move on to whatever's left. Okay, we've got the capacitors all mounted and soldered. One thing I noticed about, I'm bending the leads, kind of the one lead one direction, the other lead the other direction along the bus, and that has a tendency to have them corkscrew a little bit. After I've soldered them, when I look at the component, it's kind of twisted slightly. You can straighten that out with the needle nose. As I trim, I put my trimmed leads in a little pill container rather than let them fall where they may, 'cause I don't want the big mess. Nobody does, really. So now that we've got our resistors, our capacitors, and our diode on, I believe all that's left populating the board wise is to put in our sockets. So this circuit has an IC, a chip, as well as 2 JFETs, I think that's what that is. Those are, I should say. So I've got some sockets for the JFETs, and I've got a socket for the IC. So let's get these in. These ones are tricky because they don't really bend, so I'll show you how I deal with that. These ones is a different type of socket. These leads will bend, so you can just kind of flare them out. But there's a different problem with this one, and we'll get to that. So for these, where does this one go? It goes by the 470 along our 2N and then up 3. So it's kind of tricky to get in there. I believe it's going to go like that. And so I'll hold it in place with one hand, and what I do is I get a little bit of solder, a little glob on my iron, and I'll try to get one lead stuck, which sometimes is tricky, sometimes it's easy. So that was pretty easy. Just a little glob, and one of the 3 socket leads is stuck in place. And now on the other one, I'll solder it properly. Now we're good to go. Solder the first one again properly, and the second one, and we're good. Looks a bit crooked. Everything's looking a bit crooked here, but crooked is okay. I mean, it's in all the holes, so I'm not going to worry too much about that, or maybe I will. I'll see later. I got another chance here to make it right. So this one goes pretty close. Up there, and I'll do the same thing. turn it over. Put a little glob on. And hope that it holds in place before I burn my finger, which it didn't this time. So let's get back, reset. Kind of depends where you get the solder on your iron. If you can get it right on the tip, it's pretty easy. If it kind of climbs up the iron, you're going to have a more difficult time with this. It's not bad. I think I can do a bit better. There. And there's that one soldered. It's a bit straighter, so you know what, I'm going to see. I don't even know why this one's crooked, but I'll try to reflow it. But you know, with three leads, it's difficult to straighten because one of them is going to be, one of them's not going to be flowing. I'll just try to bend it a little bit on top here. But you know what, I'll get back to those. I might, sometimes you can lay the iron across multiple leads, straighten it that way, or loosen all the, flow all the solder that way, and then straighten out your component while it's all the leads are flowed. This one's a bit tricky because it actually lays over top of some of these jumper wires, and that doesn't give us much to work with underneath. But I'll see what I can do. I'll just hold it in place and see if I can get one of these tiny little leads sticking through. You can barely see them. Get them to stick. They really don't show very well. I mean, the connection should still be good because these are through hole. Through hole meaning that there's tin in the hole as well. Or at least I think there is, because the solder seems to flow pretty good onto this strip board. And as I say that, it's not really flowing at all. Okay, I've got that lead stuck. I'll get one on the other side. Try to be a bit generous here so that I'm sure to actually get the lead, because there's not much sticking through. If you use a different socket, you might have a different type of socket, you might have more to work with here, or if you were to just mount the IC right through without a socket, it's obviously got longer leads. So there we go, we've got our sockets, we've got our board completely populated. So in the next video, we'll be hooking this up, testing it on a breadboard, and then working on the enclosure. Actually, I might connect it to a breadboard in this video. Well, stay tuned, and we'll see. Okay, got the circuit board connected to a breadboard here. We've got our pots, and we've got our input jack over here, output jack over here. We've got it connected to my power supply. So I tested this and I checked the comments on the tag board, and I did a little mod that someone suggested. So there's supposed to be a 10K pot for volume and another 10K pot for sustain or bias for the JFETs. Now, in the original, this pot was a trim pot. It was internal. It was set at the factory and then left that way. So in this layout, they've given us the option of having it external, but the external pot has some issues. If you use 10K, the first quarter turn is silence from the pedal. Then there's a sweet spot for about the next third, and then it starts to distort at the top end. So someone suggested eliminating that bottom end by adding swapping it out for a 5K pot and adding a 5K resistor. So that's this resistor from the pot, pins 2 and 3 to the resistor to ground instead of straight to ground, and it's a 5K pot. So I'm going to go ahead and turn this on. Got my amp on, and we'll see where we're set. So that's pretty low on the sustain at 0, and we got does work. We'll up the sustain here. So the reason the author of this layout added the external sustain pot is so that if you're switching guitars, you're switching pickups, you might want to adjust it, but generally you're going to set it and forget it. So there we have it. We've got our orange squeezer built on Stripboard. Now I'll move on to the enclosure in the next video. I'm Phil, and this has been The Joy of Electronics.